the first session, which is chaired by Dr. Isam Ishaq. It is entitled Technology in the COVID-19 Pandemic. And we have in this session 3 papers. Dr. Isam with us, and he will share this session. And we maybe ask the presenters to wave so we can recognize them and allow them as panelists. We have here three presentations. I think the first one with Dua Al-Jamassi, second one Arij Musleh, the third one with Dr. Safa Nasruddin. So we can maybe, we have a plan B to play them, but we want to let them in so we can, we have here Dr. Ashraf.
Yes.
Yes, okay. And also, anyone else want to be promoted as panelist in this session?
Dr. Safa.
Dr. Safa with us?
Yes, but please promote her.
Yes, sure. Dr. Safa.
And I see Dua also is there.
Yes.
She's also having.
Dua, okay. Who else?
Dua, you didn't promote Dua. Please promote Dua.
Yes, I did.
Okay. Now she's on the list.
They are with us. I think also we can maybe allow them also to share their camera if they wish, or their mic.
Camera and share screen, of course.
We will. Okay. We have also Dr. Ashraf.
So, are we ready, Dr. Ez?
Yes, we are ready. Maybe if you like, I can share with you. You have access to their biographies?
Yes, I have everything.
You can maybe start as the program, exactly.
Okay. So, good afternoon, I think we should say now. Good afternoon. Thank you for joining us. We apologize that we are a little bit delayed, actually a lot delayed. We're almost 1 hour, 30 minutes behind schedule. So I kindly ask our presenters to speed up as much as they can during their presentations. And as mentioned, we have 3 papers. We will start with the first paper, which has the title COVID-19 Detection from Chest X-ray Scans Using Machine Learning. It's by Dua Al-Jamassi and Ashraf Maghari. Maybe you could already start to see if you can share your screen while I introduce you, so we don't lose a lot of time. Yes, okay, that's good. So.
You can introduce them and we play their presentation. It's recorded.
Okay.
Okay.
Dua obtained her PSc from the Faculty of Computer Engineering at the Islamic University of Gaza in Palestine in 2004. And she is now studying Master in Data Science in the Islamic University of Gaza. She is now a Deputy Principal at the Dar al-Arqam Secondary School for Girls. The second author is Dr. Ashraf Yunus Maghari. He obtained his BSc from the Faculty of Science, also at the Islamic University of Gaza in 1998, and his master's degree in information from the Technical University of of Clausthal in Germany in 2003. In 2011, he was awarded the Malaysian International Scholarship MIS to complete his study in School of Computer Science, University of Saint Malaysia, where he obtained his PhD in computer vision and image processing. He has published more than 35 papers in journals and conferences in the area of data mining, computer vision, and image processing. He has graduated over than 8 IT master students. His current research interests are in data science and face recognition. He is now assistant professor at Information Technology, Islamic University of Gaza. Please, the floor is yours.
السلام عليكم ورحمة الله تعالى وبركاته. My name's دعاء الجماصي. I will present to you my paper with title COVID-19 Detection from CHISIT X-ray scans using machine learning. As you know, in late December 2019, virus COVID-19 has spread widely throughout the world and has become pandemic. COVID-19 separates from person to person, mainly through the respiratory route after an infected person coughs, sneezes, talks, or breathes. A new infection occurs when virus containing participle exhaled by an infected person gets into the mouth, nose, or eyes of other people who are in close contact with the infected person. Everyday life, public health, and global economy have been destroyed. Therefore, there was an urgent need for rapid and accurate diagnostic method to detect COVID-19 cases as soon as possible to prevent the spread of this epidemic. By applying advanced artificial intelligence techniques along with radiography may be helpful in detecting these diseases. Also, the development of machine learning has a great advantages in clinical decision-making and developing computer systems. Recently, many researches were conducted on detecting COVID-19 using advanced artificial intelligence technique. There are some researches related to deep learning, and some researchers use machine learning classifiers for detecting COVID-19. One of the researches that related to deep learning used CNN models to classify the data using CHISIT X-ray images of pneumonia, and for the normal, the accuracy was 89.57%. Another one used classification model to detect COVID-19 disease based on deep features and SVM. He used ResNet 50 plus support vector machine. The average accuracy was 95.33%. Our paper focused on using machine learning approaches with CHISIT X-ray images to detect if the image is infected with COVID-19 or not. Some researchers use support vector machine and wavelets to detect COVID-19 cases in CHISIT X-ray images. He used a threshold value of 903 and scored an accuracy of 94.5%. In another research, they applied many classifiers on 194 X-ray images for healthy patients and the same number of images for patients infected with COVID-19. They applied the transfer learning and CNN trained with ImagesNet to extract the images features. Then CNN are combined with KNN, NaviaBayes, Random Forest, MLB, and support vector machine. The best accuracy of 98.5% was obtained when they used a mobile net with support vector machine classifier. Also, some researchers used support vector machine as a classification method to classify pneumonia data into 3 categories: viral pneumonia, normal, and bacterial pneumonia. They used a deep learning approach such as PGG-16 inspection V3 models. Their results showed a good accuracy of 96.6%. Our proposed prediction model consists of 5 main steps. The first step being data collection, followed by data pre-processing, which prepared the CHISIT X-ray images for feature extraction, where histogram-oriented gradients Hog feature is extracted. In the fourth step, Hog feature is trained by the classifiers to detect the infected condition of COVID-19. Final step is evaluating the performance. She-said X-ray image datasets. In our proposed model, we prepared 3 classes of she-said X-ray images datasets as COVID-19 patients, normal people, and pneumonia patients. The datasets contains 520 images as 120 COVID-19 images, 200 pneumonia images, and 200 healthy images. The datasets are divided into 80% for training and 20% to test classifiers. The datasets were collected from the GitHub website and the Kaggle websites. The next step of our model, data pre-processing. The dataset is already pre-processed and we're just resizing it to these scales so that it's ready for training and testing our model. Third step, feature extraction. After pre-processing, features are extracted from images by using histogram of oriented gradients HOG, which is a feature descriptor used in computer vision and image processing. For the purpose of object detection, the technique counts occurrence of gradient orientation in localized portions of an image. Classification. In our model, we use the 3 classifiers, support vector machine SVM, k-near snipers KNN, and random forest were used all for classification. The final step, performance evaluation. The accuracy, precision, F measure, and recall are used to evaluate the 3 classifiers. Experiments and results. In our paper, we used Python as a programming language. The extracted features from the images are given as an input to the 3 classifiers. The results show that support vector machine scored the highest accuracy with 98.14%. Our proposed model support vector machine with HOG features was compared with some related works. Our results are consistent with the results obtained by one of the related work where the mobile net and support vector machine classifier with a linear kernel are used with accuracy of 98.5%. On the other hand, our results outperformed the result obtained by another related work where support vector machine plus ResNet 50 classification model of COVID-19 images was used with average accuracy of 95.33%. It also outperformed the results obtained by another related work where wavelets and support vector machine were applied to detect COVID-19 in she-said X-ray images with accuracy of 94.5%. These results demonstrate that the using of HOG features with support vector machine can produce very good results. The classification accuracy could be more effective if we use more images, whereas the restrictions on our study was using a limited number of she-said X-ray images of COVID-19 patients. The classification can be also further improved by utilizing more images features. Thank you for listening, and I hope that the topic of my research has gained your attention.
Thank you. We have both authors with us, so we can take 1 or 2 questions if there are any. Okay, if not, I have a very fast question. In your images, did you, although it was a limited number, were they classified according, for example, to age or sex, or were it a homogeneous set of images that you examined? Dua or Dr. Ashraf, you are unmuted.
Please again.
I asked about the image set that you examined. Were they classified according to sex or age?
No, there is no.
A homogeneous set of patients.
I don't يعني أنا ما تقيدتش بأي نوع من هذا يعني just collecting it from website from GitHub or Kaggle.
Okay, so you don't know the type of patients that you are examining.
Yes.
Okay, thank you. Any further questions? I have one in the question and answer, I see. From where the authors got the data? Is it from the patients? I think you just answered it.
Yes, from Kaggle and GitHub websites.
Okay, any further questions?
Dr. Isam, maybe
another question I have here.
Some questions from the audience, you can see it maybe.
Yes, I see it now. If I want to check whether a person has corona, that means that I need also his or her X-ray image or the system after sufficient. I don't really understand what the second part is.
Yes, we must have his X-ray image.
Okay. Any further questions?
The system actually depends on the X-ray images. So we need the image before we can decide if he has coronavirus or not.
Okay, great. Okay, then in this case, we will thank you to both authors, and we'll now move to the second paper.
Thank you very much.
I said there's another question, but you can answer it maybe later, so we can keep our time. So the second paper has the title of COVID-19 detection X-ray images using CNN algorithm. It's by Arij Musleh and Dr. Ashraf Magari. Let me just pick up the bio. Okay, Arij Musleh is from Palestine. She is 39 years old and she is married and have 6 children. She graduated from Al-Azhar University, Faculty of Science, Computer Science Department. She has been working as a teacher of computer in Unruwa School for 14 years. Nowadays, she is a master student at the Islamic University Information Technology Department. And the second author is Dr. Ashraf Magari, which we have just introduced in the first paper. So we can start with the second paper.
International Conference on Promising Electronic Technologies. Our search title, COVID-19 Detection in X-ray Images Using CNN Algorithm. Presented by Arij Abdul Wahab Ahmed Musleh. The rapid outbreak of COVID-19 is the biggest issue faced by mankind today. It's important to detect the positive cases as early as possible to prevent the further spread of this pandemic. Artificial intelligence-based X-ray screening is a promising approach for COVID-19 testing. Thus, it's urgent to develop an accurate computer-aided method to assist clinicians to identify COVID-19 infected patients by X-ray images. Our study proved the feasibility of adopting a deep learning approach to help clinicians discover patients with COVID-19 through X-ray images. Depending on deep learning's high performance in the task of detection people with COVID-19, the proposed prediction model is now able to rapidly identify the patient. We experimented with applying a convolutional neural network algorithm by using a dataset of 550 chest X-ray images. We had an acceptable prediction accuracy of 89.7%. This diagram shows the stages in the research. Collect data set is the first stage. We collected 556 X-ray images divided into a training set and test set, grouped of 80% to 20%. Initialization CNN model is the second stage, which represents the convolutional neural network architecture that was used to train the dataset to obtain the best result. Fit the CNN model. The third stage is the data training process, where we conducted the training process on two groups. The first group consists of a training set containing 220 X-ray images, while the second group consists of a training set containing 446 X-ray images. Evaluation and testing. In order to verify our model, some samples of image are given to detect COVID-19. The pictures were loaded and converted into array. Then the model can predict if the image is COVID-19 or normal. Result and discussion. Throughout experience, it has been shown that with an increase in training sample, search model can achieve a more accurate identification of COVID-19 in human samples. The following table shows the accuracy results for the two training groups. And the graph also shows the percentage of loss during training. Conclusion and future works. In conclusion, the results of this research show a potential role of a very accurate artificial intelligence algorithms to quickly identify patients. In future studies, we recommend addressing other topics such as outbreak escalates, as well as trying to explore different approaches to convolutional neural networks, including deep learning models and improved interpretation of CNN models. Thank you for coming and your kind attention.
Thank you. So again, we can take now some time for questions and answers. If there are any, please type them in the Q&A section. We have both authors again here. Arij, I see she just joined, and of course, Dr. Ashraf is also here.
السلام عليكم.
أهلا.
أهلا وسهلا بالجميع وبجميع القائمين على المؤتمر، وإن شاء الله يكون البحث بلم كل البيانات والمعلومات المطلوبة أن نغطيها، وبنسأل الله أن يكتب لنا النجاح والتوفيق إلى ما يحبه ويرضيه.
شكرا أريج. Yeah, are there no questions, no comments? Okay, good. So thank you. We proceed with the third paper.
No.
So the third paper has the title Challenges Faced by Palestinian Women in Electrical, Electronic, and Computer Technology and Engineering During COVID-19 Crisis. It's by Sionaida Ismail, Noor Bahrain, and Dr. Safa Nasruddin. It will be presented by Dr. Safa Nasruddin. Dr. Safa Nasruddin is a well-recognized Palestinian leader and highly energetic educator, business and community leader who is engaged in multiple roles and initiatives through the Palestinian and regional scene. With more than 20 years of initiative management and experience in tackling challenges, Dr. Nasruddin is well known for making positive change. She seeks to inspire and empower other girls and youth in general. She is currently Vice President for Jerusalem Affairs at Al-Quds University. She headed the Ministry of Telecom and Information and Technology for 2 years and successfully introduced positive change by enabling a positive environment for telecom. She holds a strong vision for the Palestinian community through education and learning. She was awarded the Chevalier of the National Order of the League of Honor from the Republic of France in November 2017, as well as the Arab Women Achievers in March 2019, and most academician who served Jerusalem in June 2019. She's an active board member in the Higher Council for Innovation and Excellence in Palestine, also in the Palestine Incubator for Energy, the Palestine Education for Empowerment, EFE, the Arab Islamic Bank, among others. Dr. Safa Nasruddin holds a doctorate in electronic engineering from INSERIB, Bordeaux, one university in France since 2003. Please, the floor is yours.
Maybe I can share if you allow me.
السلام عليكم. I already shared. شايفين الشير؟
I noticed this. Yes.
Okay, I already
if you
shared.
like from here, maybe it's better.
نعم.
From here, maybe it's better.
عندي النت كتير منيحة زي ما بدكم، بس أنا حضرت الشير إذا بتحب. فالسلام عليكم، شكرا لكم لسمح لنا للمشاركة بهذا المؤتمر الهام. كانت الكلمات الصبح كتير مشجعة لنا، وإن شاء الله بنستمر في هذا التعاون وعمل البحث العلمي في خدمة فلسطين. ورقتي شوي مختلفة وبتركز على المرأة في الهندسة والتكنولوجيا، لأنه كل هاي الأبحاث ما بتكون إلا إذا مكننا الباحثين أول شيء، وكمان مكننا المرأة المهندسة. فهاي الورقة بدي أبدأ أنا العرض الفيلم. تفضل.
ما في صوت دكتورة صفا، خليني أعملها أنا من عندي. فيش صوت، خليني أعمل شير من عندي.
أوكي، بس أنا بقدر أعمل له صوت مع الصوت.
ماشي، فيش مشكلة.
أشوف هلا بدأ.
فيش صوت دكتورة، فيش صوت.
خليني
أعمل من عندي، خليني أريحك بس. أنا هنا دور أريحك.
ضبط، بس مش مشكلة.
تمام، ماشي. شكرا لك دكتورة صفا.
Assalamu alaikum. Good morning, ladies and gentlemen. I am so glad to be able to participate in the conference today with my paper, with my partners. I will start my sharing my presentation. Please give me 1 minute. So I'm talking about, I know the conference is about the the promising electronic technologies, but I'm speaking about the challenges that women engineers face in this important specialization. I'm a doctor in electronic engineering. I specialized and I graduated from France. And since then, I came back to Palestine, and I see that women in engineering are facing many problems, different than men. So they live in a different conditions than other men engineers, let's say. I know my colleagues here would not appreciate what I'm saying, but it's a reality, unfortunately. So the diversity is affecting negatively the women in electronic and computer engineering. And now in this different situation that we are living in the COVID, we will see the effect of the COVID itself on women engineers. So this paper was prepared by Professor Shuhaida Ismail from the University Technology of Malaysia in Kuala Lumpur, and by together with the help of one of her students, Noor Naziha Kamel Bahrain, who is in the University Uttra of Malaysia, and me, Dr. Safa Nasruddin. I'm the Vice President of Al-Quds University and in the Department of Engineering. So as I said before, COVID was spread in the West Bank and in Palestine since March, and we know from the news that it was spread by a Greek tourist who visited Bethlehem in late February. And here we see the siege that was forced by the Israelis on Bethlehem. Here is one of the gates to Bethlehem that is closed by the Israeli policeman who is standing in front of the crossing point going from Jerusalem to Bethlehem on the 6th of March. As you can imagine, Palestinian capacity for emergency response was reduced also by the Israeli military occupation and the economic turmoil that we are facing. And this was talking about in the reports of Médecins Sans Frontières, and that the Palestinians were not only facing the Israelis, the COVID-19 virus, but also the Israeli occupation increased the effect on the Palestinians. The COVID-19 pandemic also affected the Palestinian women that I'm speaking about here, increased their workload, managing multiple responsibilities, and they were more vulnerable to COVID-19 infection. We know all that women are multitasking, and especially in the time of COVID, the women were obliged to do the housework, to do the work outside home, and to manage the study for their kids, and many other responsibilities that were even worse than the daily life of the women engineers. The COVID-19 infected a larger percent on male, 64% males and 35% of females, but nevertheless the situation for women was different. If we look at the distribution per age, and according to the report from the UNICTAD, we can see that the biggest percentage was the 63% for the people from age of 18 till 50 years old. These are the working age. And less than 18 years, it was only 17%, and more than 50 years were 20%. This report was done in September 2020. So Palestinian women are often the first responders to a crisis, and they play a central role in survival and resilience of their families and the community. And we see here that the women were also the nurses, women were the doctors, women were helping in all the situation, and as I said, also women at home. So this research was based on 4 contrasts, or challenges facing women. These constructs are used worldwide, and we wanted to see how they affected women. First construct was the financial challenges, the health care challenges, the career challenges, and the domestic challenges. Here in total, we have about 29 challenges facing women, and we wanted to measure how they were affecting women engineers in the field. So these challenges are specific also. They are not only worldwide, but they are also specific for Palestine, or we adapted them to be specific for Palestine, as we see in construct 3, for example. We have the increased Israeli occupation movement restrictions, constraining job progress. We have construct 3.9, the Israeli measures causing slow job performance. We have other constructs also, or challenges that are facing women, Palestinian women, especially Palestinian women. So based on the literature, we saw that electric and electronic and computer technology engineers in Palestine helped eliminating geographical barriers and that restrict free movement, one of the challenges that we saw earlier, and the exchange of information imposed by the Israeli occupation. Also, the electric and electronic and computer technology and engineering degree holders had an opportunity to find work rate at 79% in West Bank and 89% in Gaza Strip. That leads that the effect of these engineers on the GDP, as the report of PETA shows, has a large effect on the GDP, which is the gross domestic product. That's why we wanted to see how these people were affected. This paper aims to assess the challenges faced by the Palestinian women in electronic and computer technology and engineering during the COVID-19, as I said earlier. And we want also to get out with policies that will help empowering women engineers in these fields. Most of the studies done by the UNICTAD or by UN Women or others concentrate on women with disabilities, women living under stress, or women who have different situations, but they rarely studied the women engineers or concentrated on women engineers and the effect of women engineers. So from my research, this research, we can say some demographic data here, that we targeted Palestinian women in electronic and electric and computer technology and engineering from West Bank and Gaza. Some of them lived in Gaza, and some of them were originally from Gaza but worked in West Bank. But most of the engineers that replied to our questionnaires were from West Bank and worked in West Bank. Some of them also worked in other parts of Palestine, not only Gaza and West Bank, which about 12% of them were working in other places. Regarding the degree that they had, these engineers, so most of them had the bachelor degree. About 70% had bachelor degree, 22% had master degree, and 5% of them had PhD degree. Regarding the working sector, so women, as you see, women engineers are not only working in engineering. 49% of these women who answered our questionnaire were working in the engineering field. Others were working in different sectors like education, like the service sector, agriculture, construction, research, and all the other fields. And regarding their work experience, most of our the engineers who replied to our survey had about 5 years of experience or less, and there were about 17% who had 10 to 14 years experience, and more than 20 years, only 10%. So those that we said had a PhD maybe, or others had. So regarding the working from home, so here we can see that during the COVID, some of them stayed in, so it's not the same percentage. If you see as the origin and the work, it's the percentage is different here. We can see a difference between the percentage of the people who were living before the COVID and now with the COVID, and also for the working conditions. Most of them, or 43%, worked both from home and went to work. About 34% worked only from home, and the others were 22% who worked not from home, but only at work, so they had to go to work. Regarding the marital status also, 43%, 51% were married, and 42% were single, and that's affected our results later. You will see that because 43% were single, so they were not maybe responsible for the household, and that's why we will have different results than the UN or the UN Women, the ICPET got from their results. So this is some of the data, the demographic data that we can speak about. So the research, regarding the research findings, while analyzing the data, we can say that the constructs that we used, the 4 constructs that we used, gave us 6 constructs. And here we can see that the highest challenge that we can see here is not in this group of constructs. It is here. We can see that the highest is here. It's regarding to the anxiety about the future, or we can say the stresses has the highest mean. So that means that it was most affecting the women engineers, the stresses, the freedom of movement, and their anxiety about the future and struggling to stay motivated. And you know, this situation was really different during the COVID, that was affecting not only, as we said, the women engineers, but all the others. And here we can see also, if we want to look at the least affecting constructs, we can see that the least one was here. We can see it was the poor productivity, and this is this for me is a good sign, because women engineers are never having a poor productivity. They are always working hard, even if under the COVID, even under all the situation they are facing, they have always high productivity, and they can work and manage working at home or in the work. The other other measures affecting also the ladies, as we say, the women engineers. Here we can see is it was not affecting these women engineers is the lack of healthcare, for example, 3.2 on average, and the reduced ability to provide remittance to parents and siblings, because, as we said, 43% of them were single, so maybe they didn't have this this job or this task to take care of the parents and the siblings. So these findings, we can see again that the most critical challenges faced by women engineers in electric and electronic technology were stresses, limited freedom of movement, anxiety about the future, and struggling to stay motivated. And that's why we need to do policies to encourage these women engineers and help them to progress in their work. And from these also findings of this research, we find it a little bit alarming that from the literature review and the primary data collection by established organizations like the UN Women and so on, they were dissimilar from our findings of this paper. The 11 challenges that were not affecting the Palestinian women in electric and electronic and computer technology and engineering during COVID were, for example, increased high risk due to non-ergonomic working behaviors using laptops for long hours. This can affect others, not women engineers, because we know women engineers or in technology, they are used to use computers for long hours, and also they take all the precautions that they need when using their computers. We learn it as ABC in the university while studying engineering, that there are ergonomic working behaviors that we have to respect. Higher rates of job losses was not affecting, so most of the women engineers didn't lose their jobs because they were very important for their working companies. Increased workload due to lack of social support from husband and family. So this didn't affect these women engineers, and that's why we need to concentrate not only on women engineers, but we need also to concentrate on working women in other sectors that are that need skills, that need high-skilled labor, and to see the effect of COVID on them. So also the conflict among colleagues at work, they didn't affect. Lack of infrastructure at home. We know that most of the companies provided the women engineers or their engineers by computers or the internet. We at the university, for example, we were provided by the infrastructure and the internet connection that is needed to continue our work and not stop any work that we were using already. And I believe that women engineers have all the infrastructure at home, at work to continue their work. Attending house chores while work from home, it didn't affect these women engineers. I'm sure that engineers can plan their time accordingly, and they would not be affected by this problem. Managing homeschooling also, as I said, managing their time is one of the characteristics of women engineers. Increased taking responsibility of the elderly didn't affect them, and lack of social interactions. Women engineers in general do not have or do not care much about social interactions. I think I will be, somebody will not like this comment from me, but they concentrate on work. They are hard workers, and they had less social interaction. And at last, the last point is that they are workaholic. They would like always to stay working, and that's why unable to unplug from work is one of the factors that didn't affect these women engineers. At last, the last slide will be is the resume of the findings, that we have to open our eyes on gender inequality in the regarding these women engineers in electronic and computer technology and engineering. And we have to do enough measures to empower these ladies to continue their work amidst the COVID-19 and for the future. Thank you for listening. I hope it was clear, and I'm ready to have any questions if you have. Thank you very much.
Thank you for this enlightening presentation, Dr. Safa. Now the floor is open for any questions. Meanwhile, your co-author has also joined us, Ms. Shuhaida.
Yes, please, if you can promote her as a panelist. I would like her to be with us also. Thank you, Dr. Isam. Yeah, Professor Shuhaida is well known in Malaysia for her, she wrote more than 250 papers. And she is she is supervising doctoral degree students and many people, and it's our pleasure to have her with us in this conference. She participated also in the forum, in the innovation forum, in the third innovation forum that His Excellency Mr. Adnan Samara spoke about earlier this morning, and also in the fourth innovation forum. And she helped me, we worked together on this paper related women engineers.
Yes, we're glad.
Assalamu alaikum, everyone. Yeah. Thank you.
Would you like to say a few words, Professor Shuhaida?
Thank you so much for the opportunity given. In fact, the studies currently done by Dr. Safa has been done before in Malaysia and many other countries, and we could see different patterns in terms of results. So I really hope that we could get questions from the floor, at least to see how these patterns could be enhanced towards the encouraging women, especially in Palestine.
I have one question, if you allow me.
Yes, please go ahead, Dr. Iz.
Dr. Safa and Suhaida, right? I wonder if you did similar research in Malaysia on the same topic, and if you did, were there some differences between the Palestinian society or scenario and the Malaysian scenario?
Thank you for the question. Yeah, obviously, even if you see from the presentation by Dr. Safa, the result of Palestine is totally different from the result of United Nations. And the same goes to Malaysia. Okay, for us, we did the study on specifically Malaysian women in STEM, science, technology, engineering, and mathematics, of which include, civil, mechanical, and even medical doctors and nurses. We found that the most critical challenge is, in fact, homeschooling. Homeschooling, and also, being burdened with these house chores. The fact that Malaysian women, they are too workaholics, okay, and they put a lot of reliance on childcare services, because childcare services in Malaysia are quite dominant. Okay, I would say that 80% of the urban women rely hardly on childcare services. So that is one of the major difference between Malaysian study and also Palestine.
Thank you. Are there any further questions?
I wanted to speak also about another difference that Professor Suhaida was speaking about, our study than that of the UN Women. Usually UN Women and other UN agencies concentrate on marginalized women, concentrate on women with disabilities, concentrate on other situations that women engineers have not the same situation. And that's why our results were different, and we wrote it was alarming, but we have explanation for every difference. And I hope that others in other fields will concentrate also on skilled labor, like us engineers, not only on marginalized women. And I know they need help, but also we who have the skills and have the degrees need also to be empowered and need policies for these skilled women. Thank you.
Thank you. I think there are no more questions. Okay, then in this case, then I think this session is over. Thanks for all the panelists for joining us. Thank you for the great papers, and thanks for the audience. And now I give it back to Dr. Izzuddin to announce what will going to happen with the break. How will you shorten it? Because we are a little bit behind schedule. So it's up to you to decide how we go further.
Thank you, Dr. Isam. In fact, we really need a break not as scheduled, but we will be time shifted by nearly 1 hour. So in order to give also the chance for the participants also to get some break, to go for lunch now. So I suggest now, what's the time now? It's around 1 o'clock exactly at Palestine. We have, I can see participants from Malaysia. We have participants from Japan with us, and they are still waiting. We apologize for what happened. It's not sticking to time exactly, but this happens in many conferences. I think you should be understanding to our situation, especially for this new technologies. So what we will do is that we will take a break from 1 o'clock to 2 o'clock exactly. That we start again nearly after 1 hour. No, it was scheduled as 1 hour. Unless you want maybe it to be less. Let's start again after 45 minutes. So we start at 1:45. So we lag behind the schedule by 1 hour exactly. Okay. I hope this will be good for all. We have audience here at Zoom. We have audience at Facebook page. I can see really very large number are attending and exceeded 5,000. So it's really very, very good figure that they attended these presentations. So we thank all who presented, and we will end now the Zoom meeting, and we will start it nearly 5 minutes before 1:45.